Hello everyone. Today we are going to discuss the concept of numerical integration. Okay, so numerical integration is one of the fundamental concept of numerical methods, that means numerical techniques. So in this process, that means in the process of numerical integration, what we do differently than the traditional way of integration, that means the analytical method of integration is in this process, in this way of numerical integration, we do a particular type of process, a particular type of way we apply here, so that we find the value of the function, value of the given function at different places. That means the different values of x. For the different values of x, we find the given functions value, and then we substitute these values in such a way that we find finally the value of the approximate value of the given function from from a given value of independent variable to the uh, up the another value of the independent variable. That means the we have two values of that independent variable, generally x. So that's from lower limit to upper limit. Okay, so by this way we find the integration, and this is known as the process of numerical integration in the branch of numerical method. That means the numerical techniques or numerical methods, you can say. So that is the process of numerical integration. Okay, so that's the another very different method than analytical method. Okay, analytical method of integration. Okay, so properly if we define it, the technique to evaluate definite integral using the tabulated values of the integrand is known as the numerical integration. So what's the integrand is? We know the integrand is the function which we are going to integrate. Okay, the process of numerical integration is known as quadrature when it is applied to the function of single variable. Okay, and then we go for a famous formula for numerical integration. What's this? This is Newton-Cote's quadrature formula. It is known as one of the fundamental formula, one of the key formula for numerical integration. Okay, so Newton-Cote's quadrature formula it is. So to derive this, we just draw a curve. What is y is equal to fx? That's function. Okay, and then we put its limits. What's here? So you see here, that's a value of x. The starting value of x is a, and the ending value of x is b. So we divide it in this whole area into the small strips of width h. What's the width? Is h. Okay, so that means this is the starting value of x, that's x naught. Then after we add h in this x naught, then we get x1, then x2, then x3, and such a way that we reach to xn. Okay, and for x naught we have y naught. That means y naught is equal to f of x naught from here. Okay, similarly y1 for x1, y2 for x2, y3 for x3, and similarly yn is equal to fxn. Okay, so in this way we find it. That means we divide the whole area into small strips of width h. Okay, then we write here in this way, such that x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h, etc, etc. So xn is equal to x naught plus nh. Okay, so here we find an expression for this function which we have to integrate from a to b. Okay, so that's it. And then you see here we divide the whole area enclosed by the curve y is equal to fx, the x-axis and the perpendicular lines x is equal to a and x is equal to b into a small thin strips of width h. Okay, so that's the total value of a to b is equal to x naught plus nh. Okay, so now we convert it in the form of r. So we change this x in the form of r. So we write here x naught plus rh, and when x is equal to x naught plus rh, then similarly its limits will be changed also. So when there is x naught, so when x is equal to x naught, then its limit changes to 0, and when upper limit is x naught plus nh, so upper limit goes to change n. Okay, similarly we apply this process, and then we find here f of x naught plus rh, and then we apply the Newton's forward interpolation formula. So what's the Newton formula interpolation formula is, we write this in the form of y naught plus r into first difference of y naught plus r into r minus 1 by factorial 2 second difference, plus this is in this way, and then we integrate it with respect to r, then we get this. And similarly we find the values uh, when we integrate the things with respect to r, and then we substitute the upper limit and lower limit, that means the n and 0, and then we get this. Okay, so in this way we see here what's here, this, and then we apply it, and this way finally we find this. Okay, so that means this is known as the x naught to x naught plus nh fx. So its integration is nh into y naught plus n by 2, first difference of y naught plus n into 2n minus 3 by 12, second difference of y naught plus n into n minus 2 whole square by 24, third difference, and similarly. So this is known as the Newton-Cote's quadrature formula. We can obtain the formula for Newton integration, numerical integration, by putting some particular values of n. For example, when we put n is equal to 1, then we get trapezoidal rule. When we put the n is equal to 2, then we get the Simpson's 1/3 rule. And when we put the n is equal to 3, then we get the Simpson's 3 by 8th rule. Okay, so by this way we can find the different rules of numerical integration, but this is the original formula for numerical integration, that's known as the Newton-Cote's quadrature formula. Okay, so in this video that's it, and another one we will see some another concept. Okay.